Okay guys, because I am forced to be out of the room this morning, I'm giving you guys your notes through this video. So we're going to start with sets. We have to define sets to help us talk about probability on kind of a larger scale. So today's Q&A is how do categorizations such as sets and then subsets within those sets help us organize probability scenarios. So we're going to talk about a scenario here where we've got set A. It's defined as all of the integers greater than or equal to 1 and less than or equal to 20. So every integer from 1 to 20, essentially. And we're going to represent A as a blank Venn diagram first. So we're going to say that we're dealing with a set A, and this is that set A. We don't necessarily know what goes in each of these yet. Then what we're going to do down here is come up with two subsets of A that could be represented on either side of the Venn diagram. So, I mean, we could come up with whatever we want here. I'm hoping you all come up with something different. My set B might be even numbers. And then maybe my set C would be prime numbers. You could do odds. You could do multiples of 3. You could do, you know, whatever you want. Think numbers that add up to 4. I don't know. Whatever you'd want to do for your two sets. They could be different. So in set B, we're going to have every even number that is inside of set A. So B here is a subset of set A, and so is C, where B is going to be every number from 1 to 20 that's even. So I'm going to throw those in there. And you'll notice I left the number 2 out. There's a reason for that. The next thing I'm going to do is in C, I'm going to put all my prime numbers. So let me write those in. We'll go with a 1, 3, I'm going to skip 2, 5, 7, 11, 13, 17, 19. Okay, and then I skipped 2 because 2 fits into both. It's both even and it's prime, so that's going to go in here. So 2 is the only number that crosses over there. And that's the last thing it said, is just to fill in all the values that fit in each category inside A. So that's all that is. A is all of these numbers. B is a subset. C is a subset. And they happen to they overlap right here at 2. All right? So we've got an example. In an experiment where you're going to flip a coin and then pull a numbered marble, it's numbered 1 through 4, out of a bag, write all the ordered pairs that represent possible outcomes. So, for example, you could have tails and a 3, right? So we're going to write every single possibility. So you could have, and this is going to be our set S, you could have heads and a 1. You could have heads and a 2. You could have heads and a 3. You could have heads and a 4. And you could have all the same for tails. All right. So this is our set S. So what we can do here is show that all of these are our set S. All right, so there's our set S. Now A, it's saying, is a subset of S and represents all the scenarios where a tail is flipped and an odd number is pulled. B is a subset representing heads and even numbers. What is the probability of A? What is the probability of B? So let's first identify what is A. A is any of these scenarios where a tail is flipped and an odd number is pulled. Of those, I see tail, odd number, tail, odd number. So A seems to just be T and 1 and T and 3. There is set A. And set B is any scenario representing heads and even numbers. So heads and an even number, heads and an even number. So that's going to be H2 and H4. So we want to know the probability of A. Well, the probability of A is going to be, we've got 1, 2 of our 8 possibilities. So the probability of A is going to be 2 out of 8, or 1/4, or 25%. You could leave your answer as either of these. Probability of B is also two different scenarios out of those 8 that are there. So the probability of B ends up being the same. 2 out of 8 again, 1 out of 4, 25%. All right, so that's it for the first page. We'll move on to the back.